So the question is group anagrams. So before solving this question, I would like you to attempt the valid anagram first, as that is the prerequisite to this question. So you know what an anagram is. So given an array of strings, group the anagrams together. You can return the answer in any order. So all we need to do is to group the anagrams together. So given the list, eat, tea, tan, ate, nat, and bat. So eat, tea, and ate here are anagrams. So we have list them together. Tan and nat are together an anagram. So we have list them together. Bat does not make an anagram with anyone. So we have list that separate. So given this example here, we know that act and cat here make an anagram. So we can group them together. Pots, tops, and stop make an anagram, so we can group them together as well. Hat does not become an anagram with anyone else, so we group that separately. So this will be our final output. So the first method we can use is sorting here. So taking example 1, if we sort all these elements here, we will get these. So for eat, tea, and ate, we have a common sorted element, that is AET. So for tan and nat, we have a common sorted element, that is ANT. And bat doesn't sort with anyone, so it remains separate. So we will use a map data structure here to store the elements. So as the key, we will be storing the sorted strings, and for the value, we will be having a vector of strings that will be the original strings here. So the time complexity for this solution will be m into n log n, where n is the average length of each string and m is the number of strings in the entire list. And the space complexity is O of m into n, where m is the number of strings and n is the average length of each string.
So we create an unordered map where we're storing the sorted string and the original corresponding string here. Now we will traverse over the input array, and for every single string in the original array, we will sort it, and then we place it into the map with its corresponding original string. Then we create an answer, and now we traverse into the map and push all the vectors of the map into the answer and return it.
Optimal way to solve this is to use a hash table. Here also we'll be using the map data structure. The only difference will be that the key for this map will be a hash string that we'll be creating for every single element here in the array, and the value will remain a vector of string that we have to return. So the question is, how are we going to create the hash string? So remember in the previous video, when we had a string EAT, we created an hash array of every element. Say A correspond to the 0 index, so if A appears once, then the count of that element will be 1. So like that, we will be creating a hash vector for every single element in this array, and that will be the key to our map. Okay, so for example, let's take eat. So we create an empty string, let's call it hash. Now we will create a vector of int like we created earlier, and inside that we will be counting the frequencies of each element here. So suppose for eat we get a 1, 0, 0 and something. We know that for t, which is an anagram of eat, that will also have the same hash string as eat. So it will be remaining as the same value as what the frequency count of eat was. Just like that, 8 will also be having the same frequency array as eat and t, as in every single string, A appears once, T appears once, and E appears once. So there will be 3 1 values and the rest of being zeros. So here this string will be our key here, and for every key that matches this array, then we can say that that is an anagram. So, this hash string will be the same for eat, tea and 8. So this hash string can correspond to all of these strings that will be inside a vector of string. So the time complexity for this solution will be O of m into n, where m being the number of strings in the vector and n being the average length of each string in the vector. So here we'll be using O of m extra space for the unordered map and O of m into n space for returning the output. So we'll be using an unordered map to store the hash string with the corresponding original strings. Now we'll be traversing over the original array and we'll create an empty string hash. Now we'll create a frequency vector of size 26 with every initial value as 0. Now traversing into the current string, we will increment the frequency of that character in that string. Now traversing into the frequency array, we will push the frequency of array into the hash string, and to mark the end of a string we will be using a hash symbol. Now we will be pushing the hash string and its corresponding original string into the map. Now we create the storage for answer. Now we traverse into the map with an iterator and push the second value, that is the vector of string in the map, into the answer and then return it.